Hey, I hope you had a great spring break at the beach going snorkeling and whatnot. JK. Anywho, let's review what we were doing before spring break with exponential equations. Here's the sheet that you're going to be working on today and turning in on Edmodo. All right, so before the break, we were talking about these exponential functions. Notice where the variable is. The variable is in the exponent spot, hence the name exponential functions. A couple weeks ago, we were doing quadratic functions where the exponent was always a 2. All right, it was always x squared and some other numbers too. Anywho, exponential functions, here we go. The a, that's your initial value, your y-intercept, so that's going to be 2. I'm going to put in parentheses, that's your y-intercept. Your initial value is sometimes what it's called. The base is a 3. Since that is larger than 1, that means we are growing. The domain is all real numbers. And you can use that fancy symbol, right, if you want to. That just says what can you put in for x, right? Domain is what can you put in for x. And you can put anything in for x that you want. Negative numbers, positive numbers, decimals, fractions, whatever. Okay, the range. The range is going to be based off of the asymptote, right? Where's the invisible force field? This equation doesn't have anything, right? There's nothing being added here. So our asymptote is at this line, y equals 0. So your range is anything larger than 0, right? We don't want to touch it because if we touch it, you get zapped. Okay, so to do a little graph of this guy, I like to use my calculator. If you go to that table feature and you can type in this equation right here to get a table of values. It makes it super duper easy. So we have 2 times 3 to the x. All right. And then you can tell it to start if you want at your initial value, or you can do a couple values to the left or to the right. I'm going to tell it to start at -3 and we'll see what happens. And we can always watch this, right? You can always arrow up and you can arrow down and you can find values that you want to graph. I feel like it's probably easier right in here to do the graphing. Okay, so says here 0, 2, and then 1, 6, and then 2, 18. That's going to be like off the charts. All right, so remember these grow really fast. And then you've got that asymptote right here on the x-axis at y equals 0. All right, so there's a little rough sketch of that guy. Okay, next one. We have an initial value at 0.5. The base is a 2. Since it's larger than 1, that means we have growth. Domain, you can put anything you want into these. And then the range is going to be based on our asymptote, which is -3 here. All right, so we are talking about anything that's larger than -3. All right, so let's get our calculator ready. Table, edit. All right, so we've got 0.5, parentheses 2 to the x plus 2, and then -3. As far as where to start, honestly, just start at 0 and we can arrow up and down on the chart to find values that look easier or more difficult perhaps to graph. All right, so remember as you get closer and closer to -3, right? So these are going to get closer and closer but never quite touch -3. So let me come back to this end. All right, so there's some values I could graph pretty easily. All right, so we've got -1, -2. So to the left 1, down 2. Then we've got 0, -1, so nowhere, and then down 1. And then 1, 1, so to the right 1, up 1. And then 2, 5, so to the right 2, up 5. 1, 2, 3, 4, 5. And then I bet it gets crazy. Yeah, then it starts to go really fast exponentially. All right, so we've got this asymptote at -3 on the y-axis. So here's 1, 2, 3. So we can't cross that invisible force field. And then we've got this curve that's going to get real close to it and then take off. So there's a rough sketch of that guy. All right, so you try 3 and 4 on your own. You can check it out on the answer key if you get stuck. Let me refresh your memory on solving. In order to solve the equations, you have to have the same base on each side. So you need to think of a way you can redo 81 so that it has a base of 3. All right, so here's what I'm talking about. If we did 3 squared, that's not 81, that's 9. If you do 3 to the third, no, that's 27. Gotta keep going. How about 3 to the fourth? There it is. So we can give 81 a new hairstyle. We can rewrite it as 3 to the fourth. It hasn't lost any of its value. It's still 81. We just made it look cooler. All right, so now that your bases are the same, you can bypass those 3's and focus on the powers, -n and 4. All right, so to get n all alone, we got to get rid of this invisible -1. Woo! What you do to one side, you do to the other. Negative divided by negative is a positive. So you're just left with a positive n now. And then 4 divided by -1 is -4. All right, you can try 6 on your own and 8 and 10 on your own. I'll do 7 and 9. I'll do the odds, you do the evens. Okay, so we need to figure out a way to rewrite 1 with a base of 3. Okay, so if you do 3 to the first power, that's not 1. Okay, and I know 3 squared, that's just getting bigger. It's getting farther away from 1. So I gotta think outside the box. What if I do 0? If you remember, anything to the 0 power is 1. So you can rewrite this, 3r plus 3 equals 3 to the 0 power. So we still have 1 here, it just has a new hairdo. Since the bases are the same, get rid of them. Focus on the power, so 3r plus 3 equals 0. Time to solve for r. Minus 3 to the other side, so we have 3r equals -3 now. Divide off that 3, so -3 divided by +3 is -1. All right, check out number 9. The bases are the same. That was easy. So now we just focus on those exponents. All right, I see that I have p's on either side. I need to combine forces. I like to move the smaller of the two variables. So in that case, that's a -3. So I'm going to add it to this side. So -1 plus 3, that's 2p minus 2. And now there's nothing over here. But not for long. I'm going to bring this 2 over. All right, so now I have 2p equals 0 plus 2, which is 2. Divide off that 2, and p is 1. All right, number 11. Again, the bases are the same. Yay! So I just jump right on in. This one's an interesting case. If I try and bring the ends together, it cancels. So you're just left with -1 equals -1. When that happens, that means you can put anything in for n that you want, right? These are twins. If I put a 5 in for n, then you're going to get 5 over here as well, right? They have to be twinning. So all real numbers will work. All right, you can put anything in for n, whereas on these other ones, there's only one value that would have worked. All right, so you try 6 through 12. All right, and the last thing we did were some word problems. A deer population of 150 animals, so this is your initial value. Now that's what we're starting with. Has a growth rate of 3%. So if it's growing by 3% each year, so each year time. So there's our model. We want to know how many deer there will be in 4 years. Oh dear. Let's see, 150 times 1 plus 0.03 to the 4, right? 4 years for time. We will have 168.8 deer. All right. Check out number 14. The original value of a car, right? That's your initial value, your principal. So that's what our equation starts with. Ooh, it's decreasing this time. So we want to minus the value. So minus 0.045. Remember, when you drop the percent, you move your decimal over 2 places. All right, so that's why this becomes 0.045 to time. All right, so we want to know what the value of the car is in 7 years. Okay, so initial value, $25,000 minus 0.045. And we have this car for 7 years. So in 7 years, it'll be worth $18,111.88. That's not a bad investment. Not bad at all. All right. Check out number 15. So this one's going to be a little bit different because of this word compound. All right, so if you remember from our formula before break, compound has a little extra step, right? This n is going to happen twice. All right, so our investment, that's our principal, $900. We're investing at 3.5%, so when you drop that percent symbol, it's 0.035. We're compounding it quarterly, so that's every 4, right? Every 4 months. And then 4t. All right, so we leave time generalized. Okay, so we have our initial investment, we've got our rate, quarterly, and then time. Okay, so we want to know how much we'll have after 4 years. So we're going to replace that t with 4. All right, so let's check it out. How much money do we have? Ballin'. 0.035 over 4. And then 4, sorry, need to make that a power. All right, to the 4 times 4. All right, so we're gonna have $1,000 and, $1,034 and 62 cents. Nice, not a bad investment. Free money, just letting it sit there. Okay, so take a picture of all your hard work, submit it on Edmodo, and I'll see all you cool cats and kittens tomorrow.